Okay, let's resume. So, Xingli, revision 13.
Yep.
Which were the questions you got wrong? Let me
19.
19. Wait, before that, let me just give you a quick reminder over here. When you want to calculate the value of y, sometimes you can be a bit clever and observe that y is e power 2t, 2 times e power negative 2t. So they are very similar, right? It's really just e power 2t. So you don't actually need to substitute in the t directly. You can, because you already have e power 4t over here. Actually, in fact, you have, what is it? You have e power 2t equals 2e power negative 2t. So that means these two terms are actually the same thing. Right? These two terms are actually the same thing. You can just take 2 times of that. Yeah, so 2 root 2. 2 times of root 2. Okay, but 19 is it? Oh, what about this one? 18. 18 as well, right? This guy. Question 18. You was it 18? Was it 18? Maybe I got it wrong.
This one is for 19.
Oh, it's for 19. Oh, right. Yes, correct. Okay, so basically, right, maybe the picture was a little bit distorted because of the scanning, but this is what they are trying to draw for you. You have an isosceles triangle like this, point A, B, and C. So what does it mean? It means that, and the center O, it means that these two lengths are equal, right?
Yeah.
AB equals B. And also, perpendicular bisector of the chord. This is a chord, this is a center, there's a radius. I mean, if you extend it all the way, then you get the perpendicular bisector of the chord theorem, which you already know. More importantly, from that theorem, we can show that these two triangles are congruent. And as a result, these two angles are the same. Theta is the same as theta here, right?
Yeah.
Okay. Then let me just bring up the question. Need to get a photo of the question first. Right, and let me just read the question out probably. It's question 19. So they said that the figure shows an isosceles triangle ABC. Oh, maybe I can share the screen. Yeah, I can do that. Is it showing? Yes, right? Okay. Yeah, the figure shows an isosceles triangle ABC inscribed in a circle of radius RCM and center at O. Given that angle BAO equals to theta radians and angle ADC is pi over 2, which is 90 degrees, but you use radians when you're doing differentiation. Radians.
Yeah.
Show that the area SCM square is given by that formula, hence calculate value of theta for which S has a stationary value and determine whether this value makes S a maximum or minimum. Basically follow the Desta procedure. Differentiate equal to 0, set to 0, then solve for the theta, then after that do the first derivative test. Okay, so anyways, what does inscribe mean?
Inscribe, I guess like inside. I don't know.
More specifically, not just inside, but all of the corners of that. Yes, all of the corners of the triangle A, B, and C must be on the circumference. Okay, so what does it mean about OA, OB, and OC? They are the what of the circle? Radius, right? So that means that their lengths must be all equal. Okay, so let's just go back to my iPad. Okay, so you can drop a perpendicular bisector on your own. Then as a result, you get theta and theta here, right? So what else? We already also, I just said that OA, OB, and OC, they are radiuses. So what shape do you see over here?
Isosceles triangle.
Yes, isosceles triangle, which means that this angle here must also be
Theta.
Theta, yes. Okay, maybe I should start off with a fresh triangle and show you the thought procedure. Maybe I'll just draw a smaller version here. First, I start off with perpendicular bisector. I realize these two angles are the same.
90.
That's the center. Yeah, 90 degrees here as well. I can just draw in a few radiuses. Oh, more importantly is this one, which means this angle and this angle are the same. These three angles are the same. By symmetry, I think you can also tell this angle will be the same, right? Right, it's also another isosceles triangle. Yeah, pi minus 2 theta. Okay, good. So now you have this shape here. You know that this length here is r, that length there is r. What can you okay, we have label this like green. So the green angle is what you said, pi minus 2 theta. And then you have a r and r. What theorem do you know? Half r times sine of pi minus 2 theta. That will give you the area of that triangle. Then you times 2. Okay. Can?
This
Then you
is
okay, many ways to do it. Yes, this also works. Okay.
2 pi minus minus wait. Oops.
The other angle there is also the green angle by symmetry.
Close to 4 theta.
Yep.
Then you know that both of these are so plus half r square 4 theta.
Yeah. All this part, right? Okay, good. Yeah, then you just have to combine them all together. But take note that pi minus 2 theta, sine A minus B is not sine A minus sine B. You must expand using sine A cos B minus cos A sine B, right?
Then how come when I did 19, right, then I get 4 r square tangent theta?
Oh yeah. If I'm not mistaken, yeah, I saw your working. It is also fine. You use tangent instead to go and find one of those.
But then I cannot make it into like r square sine 2 theta 1 plus cosine 2 theta.
Yeah. Have you read my working already?
Like I read that you said that if I find the SP, then it will be the same as with the one that they want, the way that they want.
Correct. But yeah, what you did was you found other formula that's exactly equivalent, because you must remember trigo identities. They're all the same. But I'm not very sure how. I haven't tried yet. How for your formula, right? It's correct. But if it is equivalent to what they want, involving both r and theta, right? The r square sine 2 theta bracket 1 plus cos 2 theta. I haven't tried yet, but if I remember correctly, it was no, this is not the correct working. It's correct as well. 4r square tangent theta. Let me double check first. Hold on a second. Half times BC times AD. Okay. BC is 4r tangent theta. Wait a minute. Hold on a second. Tangent theta equals to DC over 2r. Oh, it's wrong. Oh, sorry. Nope. Wrong. It's not DC over 2r. It's not 2r. OD is not a radius.
Oof.
Yeah. Just draw a quick diagram. There's A, there's B, there's C, there's a point O. Sorry, I didn't catch that. D. I think what you did was you're looking at this right angle triangle, right? Well, please help me. Draw a right angle triangle. You suddenly write down tangent theta equal this. I also don't know where to look. Have to guess a bit. Okay, draw the diagram. Please learn to draw diagram. You want to be engineer. We will be drawing lots and lots of diagrams, or at least looking at it. Right. Okay. Yeah. Okay. This one is radius r. Where else is radius r? here is radius r. 0.0 all the way to the
Oh,
but this length here is not.
yeah. Okay. Okay. Yeah.
Yeah, so that's why it's wrong. Sorry, I didn't catch that. Oops. Let me correct that. Wrong conclusion. Nope. Okay. Do you need me to go through with you what I did, my procedure?
Yeah.
Okay, so what you did was okay, very good. I didn't think of that. The triangle on the left, triangle on the right, they're the same, so 2 times of it, and then area at the bottom. I think you will get the same answer, but you have to massage the angle so that you get a 2 theta. But what I did instead, just to save time, I'll just tell you what I did. Was to do a bit more of angle searching. What I did is to look at this entire triangle ABC, right?
Yeah.
And then I noticed, the question asking for 2 theta. Right? Where can I get 2 theta? There.
Okay.
Right. So that means that if I don't chop it down into 3 pieces, I can actually focus on this entire red triangle. It's just half times AB times AC times 2 theta. Sine of 2 theta, sorry.
Oh, okay.
Right? Okay, that's the approach. Times, sorry, go to the next slide. Times sine of 2 theta. So the problem now is how to find AB, how to find AC in terms of and theta. I showed the working already. So here I already told you it's an isosceles triangle. So you can just use what rule? You know a length here, you know a length here, you know an angle in between pi minus 2 theta. How do you find the opposite length?
Cosine rule.
Cosine rule, which is exactly what I did at the bottom. So cosine rule says opposite side square equals to the sum of the square of the other 2 sides, which looks like Pythagoras theorem. Do you see that? Like Pythagoras theorem. If in fact, if you substitute cosine theta, the theta with 90 degrees, you'll just get a 0. Right? If you recall your cosine curve. Here is 0. Here is 90 degrees, 0. Which means that this part will just turn into 0, which is exactly cosine rule. Okay, if the angle in between here is exactly 90 degrees, you just get, which is just Pythagoras theorem. Okay, the special case where theta equals 90 degrees. But in general, you need to minus 2 times of the 2 short sides, not the opposite side. Right? Okay, they're opposite relative to each other. And multiply by the cosine of the included angle. What's included angle? This angle over here, that's sandwich in between the 2 lengths. Okay, sandwich in between. Is it okay? Cosine rule, can recall?
Yeah.
Can just using the formula. And as a result, we get this simplify. How? Just combine now. R square plus R square, 2R square. Minus 2 times R times R, minus 2R square. Multiply by cosine of pi minus 2 theta. 2R square, I can factor it out. Oh, you start to realize that it looks similar to the question already. S equal R square times something. But you have extra 2. Then factor out, you get 1 minus cosine pi minus 2 theta. Cos A minus B, if you recall the formula, it's cos A cos B. Can you recall?
Plus sine A sine B.
Very good. Yes. Okay, that's exactly what I'm doing here. But then I substitute in the A with pi, B with 2 theta. Sub in already, what do you realize? Cosine pi, sine pi, it becomes -1 and 0 respectively. 0 multiplied by anything is?
0.
0. -1 times cosine, okay, just -1 times cosine. So minus cosine 2 theta. Oh, we are starting to see it's taking shape already. It looks very similar to the 1 plus cos 2 theta in the question. Okay, minus become a plus. 1 plus cos 2 theta, just nice. Just nice. We almost have it. We need R square times sine 2 theta times 1 plus cosine 2 theta. We currently have 2R square times 1 plus cos 2 theta.
Sine 2 theta.
So where do you get a sine from? The formula law. There's the sine. The theory.
Oh, what
half times AB times AC times sine of the angle in between. But then, wow, so difficult. Now find AB, you need to take a square root. So messy. Then that's when you have to be clever. And you realize, yes, they are it's an isosceles triangle, they are the same. So AB times AC is really just AB times AB. So it's the same as AB squared, which is, if I showed the working somewhere, over here. AB times AC is the same as AB times AB. Because AC and AB are equal isosceles triangles. Adjacent sides of an isosceles triangle are equal. So AB times AB becomes AB squared. Sine of angle, the included angle is 2 theta. In this case, you get half AB squared times sine 2 theta. AB squared you sub in with what you just found. Oh, just nice, there's a half because of the formula. Half times 2 cancel away. You're left with what they want.
And what about the above, where you draw like the stuff?
Which, sorry, let me. Oh, I'm just explaining to you.
All of this stuff.
No, extra. I just wanted to explain to you why does this formula work? Half AB sine theta. I consider 3 possibilities of triangles. These are all the 3 possibilities. Can you see?
Okay.
A scalene triangle, the angle is all small meaning less than 90 degrees. All right, exactly equals 90 degrees. I forgot about that case. If theta equals to 90 degrees, acute 90 degrees or obtuse. Okay. Then you can have different. Okay, sorry. No, let me try again. So there are actually 4 kinds of triangles. First kind looks like this. All 3 angles are acute, less than 90. Second one is there's a 90 degrees, then the rest are acute, the other 2. The third and fourth one are both obtuse triangles, but labeled differently. So for the first case, I label theta here, then the 2 sides surrounding it is AB. For this guy, okay, I should have a A and B here, surrounding theta. For the third case, theta is in the middle, there's an A and a B surrounding it. But the theta in this case is obtuse. For the next case, we are using an obtuse triangle, but now the theta is acute. Theta is acute. It's the other guy. Then you still got 2 lengths that are surrounding it, A and B. These are all the 4 possible triangles that can exist. And I have listed every possibility. So now I just wanted to prove to you, I just draw all the diagrams step by step to show you that area of a triangle must be half AB sine theta. Starting with half AB, starting with half times base times height. You can derive half AB sine theta. It will always work. Do you want me to elaborate, or you want to read out yourself?
Wait, can you know how when you were saying like if you differentiate radian and like you need to change to degree?
No, if it's in radians, stay as radians. If it's degrees, then you need to do extra work.
Then you need to do like times 180 times pi, right? Or something.
No, other way around. Pi over 100.
Oh, wait. Okay, yeah. Can you show me that again?
Can. Yes. Okay, this one I think not so important. It's just geometry. Just remember this formula. That's the most important part. Here, I just wanted to give you the why. Why is it true? Why does the formula work? Yeah. Never mind. Let's just add on the page. What is the thing you wanted to know? If theta is in radians, y equals to sine theta implies that dy by dx. Okay, let me write the implies nicely. Cosine arrow dy by dx. Oh, not x, theta. Make a change, must be theta here, because we're using theta. It must be cosine of theta. That's it. No extra things. Radians. Likewise for cosine. Likewise for tangent. Clear so far?
Yeah.
I'll just write it down. Do you recall what's the derivatives? Differentiate cosine, you get what?
Cosine, you get negative sine.
Tangent you get
secant square.
Very good. Okay, that is for radians. How about else? What if we instead had, theta to be in degrees? That's when you will be in trouble. Most of the time won't occur. I mean, the questions won't give you degrees unless they are really trying to be as. But if theta is in degrees, y equals to sine, I'll just put the units, theta degrees. What we need to do is to differentiate this with respect to radians. Okay, so let's say I use a different letter. Let's say I use x for radians. Then in this case, please take note that these formulas only work when theta is the angle inside is in radians. Okay, it's in radians. Now let's take a look. What is sine theta degrees in radians? Isn't it just, if you want to convert from degrees into radians, just times pi over 180? Makes sense? The conversion rate, right?
Yeah.
Degrees to radians. This one is times pi over 180. The other one is 180 over pi.
Okay.
Technically, radians is unit loss. So just to make it a little bit more precise, I can put a degree symbol here. Okay, so over here, what I'm doing is I am multiplying the pi over 180 degrees by the theta degrees. Then if you know your units can cancel away like this, right? Then you're just left with pi over 180 theta. Okay, am I doing this right? I hope so. Then in this case, okay, I don't want to differentiate with respect to x. Sorry, I want to differentiate with respect to theta. Actually, I just realized, sorry, I don't even need the x. Yeah, this should be a starting point. I don't need an x. First, you have theta in degrees, convert it into radians. So now this is, in a sense, unitless. It's already in radians. Then you can proceed. dr by d theta. It will just be sine, cosine of the same thing. But chain rule requires you to multiply by derivative of the inside, which is pi over 180.
Okay. I think I get it.
Okay. But if you want, you can replace this back with the original unit, which is theta degrees times pi over 180. Very rare, you will not usually be asked this. The angles will usually be in radians. Okay, I just give one example, that's all. Cosine tangent should be the same. Okay, so yeah, I'm not gonna explain this. I think you read on your own. Let me know if you are interested in knowing more details. Moving on. What's the next question?
The next one is in the next exercise. Is question 15.
Wrong. This guy. 15. Yes, correct. Have you tried already?
I need I need help.
Okay, let's read through what I asked you to do. The question is asking you if you begin with this rectangle, the A, B, C, D are all on the circumference, and the length OA, OB, OC, and OD all equals to ACM. Now, if this question, maybe they 0 to 100 straight away. If you want a simpler version of the question, you can change A into, let's say, 7 cm. Okay, just pretend it's it's 7. But nah, I want to do it in general. But I'll later I'll explain. I'll ask you questions so we can think about how to approach this question along the way while I go through. So in general, it's A. What you need to understand here is that A is a fixed constant. So it's not a variable. You don't go in D area by dA. Perhaps in specific situations, you want to let it be a variable, but in this question, no, they are saying that A is a fixed constant, right? And okay, let me bring up the question in case I remember the question wrongly.
Show the largest rectangle inscribed in a circle of radius ACM is a square of side square root 2 times ACM.
Yes, good. So that means you understand that a square is a
No.
special kind of rectangle, right? No?
Wait, actually, I don't.
Huh? No? Okay. Well, I better remember to send this. I always forget to send this. Okay, so there's a family of the quadrilaterals, right? You start off with this guy. What is this? Trapezium. You might think, oh, there's only one pair of parallel lines. That's what makes it a trapezium. But no, I say you must upgrade the definition and say this means the definition to at least one pair of parallel sides. Okay, which means that it's actually a huge family. It's a huge family. There are different kinds of trapeziums inside. Did you know that a square is a special kind of trapezium?
Okay.
Right, because it has at least one pair of parallel sides. So some people like to make them different, but that's not a very smart way of doing things. You should think of them in terms of sets or subsets. Okay, they are like special cases of each other. Then trapezium is the most general. The next one will be if you add on an extra condition where you have two pairs of parallel sides, you end up with what shape?
Parallelogram.
So this one is, instead of at least one pair, it becomes at least how many pairs?
Two pair.
Two pairs, yes. But now if you add on one more condition where one of two pairs of parallel sides, okay, I label first. At least one of those four corner angles is 90 degrees, must be a 90 degrees. At least one of them is 90 degrees. What shape do you get? Still got two pairs. But then you upgrade to rectangle. So it's at least one right angle at the column. Okay. Then now if I specify one more condition, which is that opposite sides are equal in length. Sorry, no. Adjacent sides equal in length. Adjacent means they are equal in equal? No, equal in length. It will be a square. Adjacent means what? Side by side. So this length is adjacent to this length because they are side by side, right? And they are equal. Here in a rectangle, it's not equal. One is long, one is short. But I did not specify that a rectangle must have non-equal lengths adjacent to each other. Short, okay, long together with short, different length. Short with long, different length. Long with short, different length. Short with long, different length. That is just a special kind of rectangle. Okay. But you can always have a special subset of a rectangle, the family of rectangles, where adjacent sides have equal length. This will give you a square. Okay. Equal. But then as a result, all four sides are equal. Special case. What else? Just a bonus fact. Bonus fact for squares. Their diagonals bisect each other. Will be useful in coordinate geometry. So what I mean is, here same length, there same length. Actually, all four are the same. Okay, just an extra fact. There's another branch. Among this, which is the let me think carefully. Kite. Yes, kite. Wow, very bad kite. Let me try and draw isosceles. Then I draw another isosceles. Okay. Roughly like this. Okay, not very accurate, but a kite basically. Made up of two isosceles triangles. Okay, so this one, it says that you need what is it? Adjacent sides equal in length. So the condition for adjacent sides equal in length already appeared over here, right? Let me think. I'm remembering this wrongly. Right. Oh, this is at least one. At least one pair adjacent sides are equal. So here you got one pair of adjacent sides which are equal. Here you have a second pair. Okay. In fact, actually I should erase away that line in the middle. Yeah, this is the kite. But then you can upgrade the kite such that you say that it instead of having at least one pair adjacent sides equal, you can now have at least two. What does it mean now? This pair adjacent equal. This pair adjacent equal. This pair adjacent not equal. This pair adjacent not equal. But that's okay because we only need one pair. This one got free gift, got two pairs. This one says at least two pair. Oh wait, maybe no, not two. Sorry, at least three. At least three. What shape will you get? Eh? Also not correct. This one should be two. I'm so sorry. I'm not remembering this correctly. This is two. One pair, two pairs. What happens if you upgrade to three pairs?
3 pairs.
This pair same, this pair same. Where's the third pair? Must be here and here. But one long, one short, so cannot. You must adjust. It must be a family of quadrilaterals. Sorry, I didn't put at the very, very, very top. Quadrilaterals. Four-sided figures. One long, one short, cannot. Then how about if we make this longer, a bit shorter? How about this one? Or this one? This one, middle one, maybe not equal yet, but this one definitely equal. So what shape do we get?
You get
Diamond. No, not diamond. Professional name is rhombus. Okay. Can then now if you combine with the rule, you see this rule, at least one right angle goes from rectangle toward a square. If you apply the same rule over here, like this, it's the same rule. Maybe I will copy this rule and put it somewhere nearby that. Nearby, like this. Okay. When this rhombus has at least one right angle, it will become a square. So a square is a special kind of rhombus. A rhombus is a special kind of kite. A square is a special kind of kite. A square is a special kind of rectangle. A square is a special kind of parallelogram. A square is a special kind of trapezium. So on and so forth. You get what I'm saying? I realized actually, oh sorry, this one is wrong. This one requires at least one pair of parallel sides. These are all not parallel. So separate branch. No, it branches out directly from quadrilateral. Yeah, that makes more sense. Sorry. That's the flow chart of the quadrilaterals. Okay. So yes, basically for this question, they're saying that you have the largest rectangle inscribed in a circle, then you want to show that it will become a square. Because a square is just a special kind of rectangle. Okay, understand? Then you must be thinking, but my normal thought process of my normal visualization of a rectangle is one long, one short, one long, one short. But now you want a square. That means it's all four equal. So what's changing? Long becomes shorter, short becomes longer. Make sense?
Huh?
No, don't get it. Okay. You have a rectangle, I'm sure you agree that usually it looks like long, short, right? But now it becomes a square. When it becomes a square, it means it becomes what? another possibility like this.
Oh, okay. Yeah, okay.
Another possibility like this. The four corners must remain on the circumference of the circle. Maybe I should have started off by reminding you again what is inscribed. Inscribed means that all four corners are touching the circumference of the circle. So there's all these possibilities, right? So what is changing? What is changing in all these shapes? That's what I was trying to lead up to. You see, one is long, one is short. Wow, this is a very bad diagram. I shouldn't be drawing with my mouse. Let me change the screen back to my iPad. Okay, there's a long, there's a short, but square is all sides are. All four sides are. All four sides are. I'm just waiting for you to reply me. A square has all four sides being
Same length.
yes, equal, same length. But one is long here, one is short here. How can this be a square that you know of? It must mean that the long length must become
shorter than the short length must become
shorter,
longer.
must become longer. So now you got lengths that are changing. In other words, they are varying. So that means that they are variables. Make sense?
Okay.
Right. You must remember calculus is all about studying the rate of change, right? So what's changing? A variable? Okay, good. So now you have identified these two lengths, right? And what's so special about what's so important about these two lengths is that they help you to find the area of the figure, right? When they tell you they want the rectangle to be as big as possible, it's equivalent to saying they want the area to be as big as possible. Maximization of the area. Right? So your most important step one, maybe step zero. Okay, step one is to first find a formula for the area. And you can do that by drawing a picture. Is that clear? As the first step. Okay, yeah, you label it here, draw the diagram. Then your second step is label your own variables, but maybe it may not be the first step. You can jump around between step one and step two, just keep thinking back and forth. You must read the question and figure out that they said largest, was that the word they used? Let me double check. Yeah, largest rectangle is the same as largest area. Then you must think, how do you find area? Length times breadth, right? Then what do you think is the length plus the breadth? Must be here and there. Okay, but if you call them L and B, that means that they are variables. Means that they are changing. Why would they be changing? Because of the picture I draw for you just now. Here's another possible rectangle like this. Oh, very bad. Let me try and make it look nice. Then here's another one. There's another one. So all these are possible. So which one? I hide the diagram. Sorry, I can't show it all on the same screen. So that means you got length and breadth variable. So what do you need to come up with yourself in order to find the area? You will need to come up with a L and a B, or if you like X and Y, for those two lengths. Does it make sense so far?
Yeah.
Okay, so you label L and B or X and Y. Okay, that's the answer to the first question. Then how many independent variables are allowed on the right hand side? If you recall this example, let's say volume of water, V equals 1/3 pi r square h, right? Base area times height with an extra 1/3 because it's a cone. Are you allowed to differentiate straight away dV by dr, dV by dh?
No.
No, cannot.
Make
Why?
one in terms of the other, is it?
Yes, correct. Right hand, in other words, your right hand side can only have how many variables?
One.
Types. Only one type of variable. Okay, only one type. Okay, so that's the answer to this question. Only one. So that was just to remind you, only one. Okay, but with a rectangle, what's the area of our rectangle? It's a length and a breadth, right? So the area is x times y. In other words, please don't use the English word area when you're in math class. Just use a symbol. I mean, you can write it down. It's clear. It's very clear. It's very good. But you can put down like this, area, comma, capital A equals xy. Okay, we want to dA by d something, right? So it's always a single letter. Don't use English. Use a capital. Also, use an equal sign. Why are you still using an arrow? Don't need arrow. It's exactly equal. It's exactly equal.
Okay.
Okay. But there's a problem here. X times y. How many variables do you see?
Two variables. Make
types of
x in
variable.
terms of y.
Exactly. Then that's the problem now. How?
Yeah, how?
How? Look at the diagram now. I label it nicely for you, x and y. All right. What you notice also is that because this is a rectangle, if you just try and draw it, you'll realize that OA, OB, OD, OC, they are all radiuses of the circle, which means that if this is length A, which was given in the diagram, all the other three must also be A.
Mhm.
Also, because it's a rectangle, what's the angle over here? Okay, the answer is already on the left side. But what's the angle over here? 90 degrees, of course, rectangle, right? Then BDA is a right-angled triangle with all three corners on the circumference of the circle. What property do you remember about circles that have a 90-degree triangle inside?
Properties do I remember?
Right-angled triangle inside. What shape is this?
Or 90 angle in a semicircle.
Semicircle, yes. Okay, actually, is that important? Not really important, but maybe you could have started off that way. If instead of realizing it's a 90 degrees in a rectangle, you could have started off by noticing P and D are points on the circumference. Join them together, get diameter. Oh, then you see semicircle. Then as a result, right angle in semicircle, you realize it's 90. What is so important about knowing it's 90 is that you can now use
Picasso.
X. What? No. Picasso can, but you need to define an angle, which will make the question.
Okay, no, never mind.
Second method.
X
I can show you.
plus y squared
That's y squared.
equals
Equals
to
to?
b.
BD squared. Yes, correct. Hypotenuse. But what's BD? Just treat this as like 7. If you know this is 7 and 7, what's the total length?
2a.
7 plus 7. 2 times 7, which is 14. But this is algebra. We use letters, so it's 2a. Yes, correct. Is it 2a? No, you need bracket square. Exactly. That's what I have here. A plus a is 2a. 2a squared becomes 2 squared a squared, which is 4a squared. I'm not writing this down. Maybe I should write it down. Which becomes 2 square a square, which becomes 4a squared. Okay, can, right? Good. No, this is just numbers. This is not a variable. Okay, a is just a number, so it's just some number, whatever. These are the two variables. Remember your area of the area of the rectangle is a equals x times y, right? You have to come up with this formula on your own. Okay.
Okay.
Yeah. Must translate the question. Largest rectangle into area. Then you come up with length times breadth on your own. X times y, and you must know you need the variables x and y. Oh. Okay, but the problem was that there are two independent variables on the right side. We don't want that. We only want how many?
1.
1. So
y in terms of x, which is what you did here. Then you submit.
And
then you can differentiate.
Yes, and then you can differentiate. So that's exactly what I did next. A equals to x times this guy. Then you just differentiate with respect to x. Then the rest is just that star. I'm sure you know how to do, right? In terms of A. Okay, that is method 1. There is another method, which is what you were saying, Wakaso, right? You can, okay, wait, just to finish up the question. After you do the procedure, I'll leave you to read on your own how I solved it. First derivative test, blah, blah, blah. Okay, now I want to emphasize a little bit on this first derivative test. After we get the x value, I'll just square root 2a. Okay, right? Because dA by dx, you solve for x. We do first derivative test to show that it's a maximum. But there's a problem. You cannot use a calculator here, right? If you want to sub in the calculator and realize it's positive. Do you notice that? Because it's a A, it's a letter A. So how do we prove that it's positive? This is when this question is getting a bit out of hand, a bit out of AMAX syllabus already. It's quite challenging. So here is how I did it, my approach. I just let delta be a this is a Greek letter, like this, delta. I let delta be a small positive number, small change in x, sorry, it's a small positive number, delta more than 0. Then when I say root 2a minus, what I mean is I take the root 2a, the value, but I subtract a small positive number, whatever it is, very, very small, okay? Just to make it look nicer, I rewrite it as square root and 2a squared underneath the entire square root, minus delta. Now the question is, what is the sign of dy by dx after you sub in this smaller, slightly smaller value? Okay, sorry, how do I say it? Value which is slightly smaller than square root 2a, right? So what I did next is I took my dA by dx, which I found previously over here. I replaced the x with root 2a squared minus delta. Okay, the slightly smaller version. Can you see what I'm doing here? Okay, then I continue to expand the whole thing. Please take note that a minus b bracket square is not a square minus b square. A minus b bracket square is not a square minus b square. Instead, it is equal to a square minus 2ab plus b squared. So that means that you need to expand all three terms. Okay, getting a bit messy, but can understand so far? Right, I'm just substituting with a smaller value, then trying to do it manually. Because I really cannot use a calculator here because it's a letter A. So I just expand it and then I continue to simplify, multiply the -2 inside, so on. And then eventually I get to this expression. Then I have a problem. Let's examine this. Wow, how do I know whether this is positive or negative? This is dA by dx, sub in the x with the root 2a minus. How do I know it has to be positive? But how do I know it's more than 0? If a was 7, it would be easy. You can just use a calculator. And if I know what's delta, 0.001 maybe. But now don't have, then how? That's when you need to really understand your math notation. First up, square root here. By definition, it will always be positive. Very good. So this is a fraction. Denominator is positive. Okay, you got a fraction, positive denominator. Now, if you want this to be overall positive, more than 0, right? More than 0 means positive. What does the numerator have to be?
Positive.
Has to be positive as well. Sec 1 math, you learn positive divided by positive gives you positive. So that means that the numerator has to be positive. Then that's our goal, to show that this fella here is positive. And that's exactly what I did next. First thing I realized is that A is just a constant, right? It's just some number, 7, 8, 9, whatever it is. The only thing that's changing over here is delta, right? Delta can be 0.1, can be 0.01, can be 0.0001, right? You plus and minus a small number. You get the idea? So that means that delta is actually a variable. So what I can do here is I can draw a graph of this function. It's getting a bit complicated with a lot of letters, but let me try and break it down for you. So the numerator there, I have a letter A, just pretend it's a number. So this 4 times square root whatever is just a number. Multiplied by a delta, then there's another number followed by a delta square. Is that okay? Can So to make things more familiar to you, I'm gonna do a substitution. I'm gonna let capital X equals to delta. So here we get y equals to 4 root 2a squared times x minus 2x squared. So it's really just a quadratic expression in terms of x. Can you see that?
Okay.
Something x minus something x squared. But there's a negative sign, so it must be a set phase. And I can also factor out the x, then I end up with 4 root 2a squared minus 2x times x, which means that if I want the roots of the graph, I can just set this y equals to 0. Like, remember, this is y. Solve for x. I end up with what? I get x equal to 0, and I get x equal to 2 times square root 2a squared. Is it clear so far? So, question. This value here, positive, negative, or 0? If a equals to 0, what happens? If a equals 0?
If A equals 0, then inside becomes 0.
Square root 0 is 0, then 2 times 0 is 0. But can A be 0? What's A?
No.
A is the what of a circle?
A
Is the length of the what of the circle?
length of the radius of the circle.
Radius. Okay, more importantly, it's just a
positive.
length. So it has to be positive. So that means 2a squared also positive. In fact, the square there will make it positive. Yeah. Then positive 2 times a positive gives you positive. Square root of positive, still positive. Okay, 2 times positive, even more positive. So confirm without a doubt, even without knowing what's the letter A, I know the graph 2 root 2a squared. Oh, I just realized I made a mistake. This should be a 2. Sorry. How many change this to a 2? 2 root 2a squared must be on the positive part of the x-axis. And the other root, 0, must be on the origin itself. And it's a set face, right? Negative coefficient of x squared. So I have a graph that looks like this. Do you get how I draw this graph now? Graph sketching, okay, good. So now that we know how the graph looks, let's take a look at what happens to the graph. X here is the delta, and it's actually representing that plus minus 0.001, right? And it's always positive. We want a positive change, right? So can we have x to be negative, the delta to be negative? No, cannot. What is delta? Delta is the small change. Small change, it's more than 0. I'm adding and subtracting the 0.001. 0.001 is a positive number. Can understand the idea?
Yeah.
Right? It's like when you want to sub in into the calculator to get the value. Did you actually try and do that? Or you just get to the conclusion and fill in the blank? I don't know. Just understand that you're adding and subtracting a small value of delta from the original. So in that case, delta is a positive number. Then that means that this part of the graph actually is irrelevant, this part, because we cannot have negative value of x. Also, this 2 root 2a squared is actually what happens. Let me double confirm. Yeah, okay. The x value could be bigger than this x root 2a squared, but let's just ignore it for now. Okay, let's ignore it. If we allow our delta to be trapped in between 0 and 2 times root 2a squared, what do you notice about the graph? With respect to the x-axis, is it above or below?
Above.
Above means that the y value is
Positive.
Positive. Oh, but what is the y value referring to? It's this yellow color highlight, which is this guy here, which is the numerator of this guy. So we have just shown it's positive.
Okay.
Provided that the delta we choose is in between 0 and 2 root 2a squared. Do you remember asking me a question about how small is small? How small is small? Plus and minus a little bit.
Yeah, the negative, the 0.0.
Here's your answer. Must be smaller than this 2 root 2a squared for this specific question. This is the algebra that you need to do to work it out. How small is small? I try to answer your question. The answer is, in order to make sure the question makes sense and you can have a turning point, you need a positive dA by dx, right? Over here, right? Positive 0, then negative. In order for this question to make sense, you need this positive sign, which means that the numerator here has to be positive, which means that this expression here, you need this part of the graph, which is above x-axis and positive, which means that your x values must be in between 0 to 2 times square root, whatever. How small is small? This is the range of values that are allowed. That is the definition of small. Okay. Yeah, x is small means smaller than, sorry, not 4, it's 2 root 2a squared. Okay, very good. So the rest is just explaining in more detail, like positive over positive gives you positive, right? Now, similar argument will apply. If you want to do it, I will leave that as an exercise for you. for root 2a plus, slightly positive. So plus a delta this time. You'll realize that the dA by dx, after you sub in that value, you get a negative. Okay. So you get the first derivative test done. A second way to do this, another way to do this for the delta, right, is to do second derivative test, right? So you just differentiate, get a second derivative, but this time you have to sub in x equal to root 2a itself. This case, if I am not mistaken, you will get a positive value. No. Actually, in this case, it's a bit more difficult. It's a bit more difficult. Because you need to prove, you need to explain clearly why this should be positive. And this is a monstrous looking inequality that you need to solve. Show that this is more than 0 or a bit. Sorry, actually second derivative test should be less than 0 for maximum point, right? Am I remembering correctly? Yeah, so a bit challenging. So don't do second derivative test. Okay, especially when it's in terms of A. Now there is yet another method to do this, which is what you were saying just now, right? Picasso, right angle triangle. Are you following so far?
Yeah.
The method 1, okay. You can go and read the details later. The second method is you can let theta be one of the angles here. Okay, let's go back to our quadrilaterals flowchart. Quadrilaterals means four-sided figure, by the way. Let's go back to this bonus fact in a square. I said diagonals bisect each other. Let me just give you another bonus fact. What do you think is the angle over here? Okay. What do you think is the angle over here?
45.
45 degrees. How about a rectangle? Let me ask you. Common mistake made by primary school students and secondary, every level. This angle and this angle, is it also 45 and 45?
No.
No, make sure you get that. Wrong. Only for a square, then you can have 45 here and there. Even though for a rectangle, another bonus factor, the diagonals bisect each other. Okay, actually all four are equal. So you have an isosceles triangle here and there, and here and there as well. Okay, but now that you know it's 45 degrees, that must mean that it's a unique feature of a special kind of rectangle known as a square. You see, previously, okay, I better not write 45. I will put in some actual angles. Let's say, for example, I don't know, 20 degrees, and the other guy must be 70. In order for a rectangle to turn into a square, that must mean that this corner angle here must upgrade itself, change itself into 45 degrees. Does it make sense?
Mm-hmm.
So that means what we can do is we can let this changing angle, it's varying, right? Sometimes 20 become 45 or 70 go to 45. So it's increasing or decreasing, it's changing. We can introduce a variable to represent that angle over, let's say here. Okay, of course it could be at the bottom or the top, it doesn't matter. Then from there, we can construct a formula for the area of the rectangle in terms of theta. Right, just like the previous question about the triangle inside a circle. Now just upgrade to rectangle in terms of theta. Then after that, you carry on with differentiate with respect to theta equal to 0, solve for x, or solve for theta, sorry. That will also work. Okay. But it's not very effective to solve this question because if you read the question, they ask for a square of side square root 2a cm. So they're asking for a length. Here you go and solve for theta, you do so much work, you solve for theta. At the end of the day, you still need to do a bit more work to go and figure out what's the length. So you need to do like 2a times cosine theta, right? Cosine theta is adjacent over hypotenuse. Then you have to multiply by the hypotenuse to make the adjacent the subject. So 2a times cosine theta before you can get the final answer, square root 2a. I think you should try this. Try this other method. Try the question 15 again, but use an angle theta. Find another formula for the area of the rectangle in terms of theta and little a. And maybe if you want, you can keep the y or keep the x. But that would be a little bit challenging because there will be two variables. You need to get rid of one of them. Okay, Ken, try yourself. Let me know. Send me your attempt. What is the area of the rectangle in terms of theta? I haven't tried it myself. I'm not so sure. Ken?
Okay.
Yeah. I'll pick any other letter you like. Just follow this procedure. Really. You must train your problem solving. Draw the diagram, label your own variables, figure out. The question is really just asking to maximize the area. So you need to figure out what are the variables you need to find the area. Okay, that's the challenging part about differentiation. The first step, the setup of the equation. The rest is just testa, very simple. You've already done countless number of questions. You just need to learn the first step. Create your own formula. Okay, next. What else? Any questions?
No.
Let me know if you have. Yeah, move on. What's this? Question 15? Oh, yeah, I explained already. 16, anything wrong? Don't use arrow, use equal sign. Yeah. Oh, and then just one small point over here. Please don't say reject square root -4. The negative underneath square root. You go and type in a calculator, what do you get? Square root of -4.
Math error.
Math error. It's not because you did the question. It's not because you will get this as one of the roots. It's because you write wrongly. Here plus minus square root 4 is actually the same as x equal plus minus. What is square root 4? It's 2. So it's actually plus minus 2. So there are two roots. But what you've written over here is x equals square root -4, which is a math error. It's not a -2. It should be a -2, not square root -4. In the future, you might learn about complex numbers. So here, when you have square roots underneath when you have negative under the square root, you will end up with complex numbers. For example, yes, square root -1 is I. For example, square root -4, you can rewrite it as square root 4 times -1. So you can write it as square root 4 square root -1. Square root -1 is actually I, square root 4 is actually 2. So you get 2I. Whatever is I. I don't want to explain further, but yeah, do not put negative under the square root. Not yet. Okay, next one. Yeah, your working is fine, max area. Is that all?
And then there's the next worksheet.
The next one, I think I marked already. Which one? Is it this guy? Did you send me already or did I not?
Yeah, it's the review exercise 16.
Do you send me already or something?
Yeah.
Wow. Let me see. Oh, sorry, I didn't open that. Oh, you sent a third one. Oh, sorry. Okay. Do cost given different cost per square for cost size versus top and base. Oh. Give me a second. I will go download it now. Oh, okay. Right. Oh, yeah. Okay. Back. What is revision exercise 16? Let's see. Right, this one. A4, A5, B6, and B7. Wanted some application questions. If I remember correctly. Okay, let's take a look. So A4, a piece of, wait, before that, did you say something? There was a comment underneath IE16. Not sure how to do cost given different cost per square. Oh, that's B7. Oh, remind me about what you're gonna say in B7. I'll read it later. Okay. Can I?
Say again.
You said you remind me about the question B7. You have something to say in Telegram.
Oh yeah.
I don't know. Tell me later. If not, I cannot remember. Okay, next one. The first one, A4. A piece of wire length 2,400 cm is used to make the edges of a rectangular box, as shown in the diagram. Okay, so there are how many edges? How many edges?
How many edges
In a box.
in the box?
The frame. To make the frame of the box. How to draw a box?
Like yeah, like that. Lor.
How many?
How many edges? Wait, how do you? 1, 2, 3, 4. Wait, edge means just the corner, right? Like just this thing.
No. Edge is the lines. Vertices
Is the
are the
lines. 1,
Faces
2,
are the
3,
flat one.
4,
Oh.
5, 6, 7, 8, 9, 10, 11, 12, 12.
Okay, very good. Okay. Number of edges is 12. Huh? What's the number of vertices? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. Corners are corners. What's the number of faces? F. How many sides are there in a die? Singular of dice.
6.
6. Okay, so let's do a funny formula. V is it V minus? Do you know the formula? If I am not mistaken, the formula was what? Right. Right. V minus E plus F. Yes, correct. What is V minus E plus F? Oh, where's my
V
F?
minus E plus F. 8 minus 12 plus 6. 2.
2. Very interesting. This is a very common, very, very interesting pattern because there are other shapes that also have this pattern. V minus E plus F equal to 2. Is it relevant to this question? No. Just want to let you know. This is a constant. It will always be 2 for certain shapes. You can go and Google this. V minus E plus F. What was the name? I forgot the name. I'll let you know another time. Okay, moving on. A piece of wire. Okay, it has a length 2,400 cm. Make the edges of the rectangular box. How many edges? 12 of them. As shown in the diagram. The box has breadth x cm, length 3 x cm, height h cm. Part 1, find h in terms of x. Okay, so that just means it's a very interesting perimeter. The length of this entire wire is 2400 and you use all of them, right? So that just means you need to find out what's the sum of all of the edges. So in this case, 2 times of 3x, 2 times of x, 4h. Let me see, is it correct? Oh, then you make 2 times of 3x and 2 times of x again. You could have just went for 4. Ma. 2 plus 2 is 4. 2 plus 2 there is also 4. You see? 1, 2, 3, 4. Oh my. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Can you see that? Right, so you have 4 times of the same length. So you can actually also write it as 4 bracket of 3x plus x plus h. A bit faster. A bit faster. Okay, but anyways, your working is fine. Let me just double check. You end up with 16x plus 4h equal to 400. Is that right? Correct. Yes. Equals to 400. Next one. You want to make h the subject. So bring the 16x over, you get minus 16x. Divide by 4, you get 600 minus 4x. Good. Part 2, find the volume V equals to 12x squared 150 minus x. So volume equals to base area times height. Please use an equal sign, not arrow anymore. Base area in this case, 3x times x, okay? Multiplied by the height h, good. But there's how many variables do you see here? Types of variables? Okay, there's 3 variables, but the types of variables is x and h, 2 types, very good. Can we have 2 types?
No.
The answer
One
already asked for x.
other.
Very good, which is exactly what you did in part 1, 600 minus 4x, sub in. So now you get 3x times x, 3x squared, sorry, on the left side, and then multiply by the h, which is 600 minus 4x. Distribute, you get what? 1800x squared minus 12x cubed. Okay, correct. Then you can factor out 12x squared, you get whatever they want. 12x squared bracket 150 minus x. Part 2 is fine. Showed. Very good. Yeah, that's the proper way to present it. You need to answer back to the question. Show, shown. Proof, proven. Okay, dv by dx, next one. Find the value of x or h, the volume as a maximum. Yeah, just follow that style. Differentiate it equals 0 of x. Let me just quickly check it out. Of x, you expanded it again, okay. Factor out 1800, differentiate x squared, you get 2x, 2 times 18 is 36, okay. X cubed, you get 3, differentiate, you get 3x squared, 3 times 12, 36. Okay, good. Set it equal to 0, okay. Good. Divide by 36, 100x minus x squared, factor out the x, you get 100 minus x, good. Solve for x, good, good. Okay, sub in, this must be our maximum. So if you just sub in a smaller value of x, here maybe, instead of saying x minus, this is the, you know what? Okay, never mind, can, this is fine. X minus x plus makes sense. Okay, so you find the sign is positive, 0, negative, and then the gradient upward sloping, horizontal, then downwards. Okay, can, very good. Just have to sub in a smaller value of 100. Like let's say 99.9 or 100.1 or 0.001. Sub in into the original into the dv by dx expression, which is this guy, 3600x minus 36x squared. You get positive, you get negative. Okay, next. Therefore, you get this value of x, which is it 0 or 100? It must be 100. Cannot be 0 because it's reject, because the length must be positive. So your rejection is correct. Value of x being 100 will give you the maximum. Oh wait, value of x for volume is maximum is 100. Okay, yes, can. Next one. Is it A5? What did I ask for? A5, yeah. Okay, let's take a look at A5 now. Another wire, okay. A piece of wire 100 cm in length is divided into 2 parts, a bit more tricky. One part is bent to form a square of side x cm. I am amazed that you can do this question without drawing a diagram. Have you drawn it? No, never draw. Wow. Okay, try to draw. Try to draw. It will help you a lot.
No, yeah, I think happened. It's cause like the question is like on my iPad. Then like I think I just draw on my iPad.
Oh.
I think that's why.
Okay. Can. Why don't you just do on your iPad?
Because I don't know. I feel like if I don't know. It just feels like it takes longer.
Oh, okay. Can. Sure, go ahead. Yeah, this is very good. People can see very clearly. Okay, let's just draw the diagram now. So one point is bent to form a square of side x cm, so x all the way, because all four sides of a square are equal. And the other to form a square of side y cm. So again, it's a square. Okay, maybe it's different length. I just assume it's smaller. I'm not sure. All four sides equal as well. Total is 100. Total is 100. Okay, total L equals 100 length. Part 1, express y in terms of x. Okay, let's see what you did. 4x plus 4y. Okay, makes sense. Make 4y the subject, divide by 4. Okay, good. Next one, part 2. Show that the total area ACM squared enclosed by the two squares is given by this formula here. So everything is in terms of x, right? A equal x squared plus 25 minus x bracket square. Oh, so total area is x squared plus y squared. That's correct. Don't need to put arrow, put equal can already. Also, don't need to bracket a, just a equals. It's perfectly fine. Can? Notation, this one. Very important. A equals. Then after that, you realize, oh, you need x only, but here you got y. So you just replace it with y equal to 5 minus x, which you can obtain from the previous part. Sub in with the brackets. Good. Next one, part 3. Find the value of x for which a has a stationary value. Determine whether this value of x makes a maximum or a minimum. So the standard procedure that's right. Let's see. Differentiate a with respect to x. So, before you did that, you expanded. Okay, smart. So you don't have to do so much work about chain rule. Can. So in this case, you get 625. Is it 25 square? Is it 625? Let me double check for calculator. Okay, where is my calculator? Right, okay, 625, yes. 625 minus 2 times 25 times x, 50x plus x squared. Okay, good. Then in this case, you get 2x squared minus 50x plus 625. Good. Differentiate, you get 4x minus 50. Good. 2 times 2 is 4. Okay, differentiate, equate to 0 for stationary point. Solve for x. Good. First derivative test, sine of dA by dx gradient. Oh yeah, here actually you could have also done d2a by dx squared because it's quite simple, right? What is it equal to?
4.
4, which is more than 0. Therefore, this is a what point?
Therefore, this is a minimum point.
Minimum point. That's it. At where? At x equals to 12.5. This is the most efficient way to write it already. Minimum point at x equals whatever. Or maximum. Less than 0, then maximum. More than 0, minimum. Okay, Ken, very good. This looks fine. Yeah. Ken, V6. Let's see what's V6. Scroll down. The lengths of the sides of a triangle are 6 plus x, 6 plus x, and 16 minus 2x. 6 plus x, repeat. So it means that it's a what kind of triangle?
It is.
What is it? Two lengths are the same, so it's a isosceles triangle. Yeah, you already draw it. Okay, you understand. Good. So then let's take a look up. Part 1, show that ACM squared, the area of the triangle, is given by a equals to bracket 8 minus x times square root 28x minus 1. Okay. Okay, let's take a look at what you did. 16 minus x divided by 2, you get 8 minus x, correct? That's the base here. H equals to, just use Pythagoras theorem. So 6 plus x bracket square minus 8 minus x bracket square, take a square root. Expand the 6 plus x square, you get 36 plus 2 times 6 times x, which is 12x, plus x square, good. Minus bracket, good. 8 square, 64, good. X square is x square. Minus 2 times 8 times x, minus 16x, very good. Multiply in the negative sign, you get minus 64 plus 16x minus x square. X square cancels away. 16 plus 12 gets 28x. 36 minus 64 is a number. Let me double check. 36 minus 64 is negative 28. Okay, good. Area is now half. Don't use this arrow notation. Don't need to spell it. Just A is fine. Capital A. Half times base times height. Okay, so 16 minus 2x times the h, which in this case you found to be square root 28x minus 28. Good. 16 minus 2, we can factor out a 2, become 8 minus 1x. 2 times half becomes a 1. You don't need to write it down. Good. You can also factor out 28 from 28x minus 28 within the square root sign. Okay, very good. Okay. So part 2, find the value of x which makes a maximum. Wow. Okay. Differentiate this guy. Power half. Yes, because square root. Okay. Then you just have to realize it's a product, right? So you need to use product rule. Oh, okay. So differentiate this guy, copy the second guy. Okay. Then keep the first guy, differentiate the second guy. Can bring down the half, minus 1, you get negative half, differentiate 28x minus 28, get 28. Very good. Ooh, okay, I'm gonna skip the one you scribbled away.
Yeah.
Okay, okay, can then this one, negative 1 times this guy to the power of a positive half. It's just a square root. Okay, this is fine. Good. Next one, you get half times 28. You can cancel away, you get 14. 14 times 8, you get 112. Is that correct? Let me double check first. Yep. Okay, and then 14 times negative x. Get negative 14x. Good. This guy, power negative half, bring down, become power positive half over here. Then you rationalize, multiply top and bottom. Okay, okay. Perhaps it would have been easier if you did a bit of simplification. Like split it out as square root 28, square root x minus 1. I don't know, is it actually easier? This is 4 times 7. So square root 4, square root 7, which is 2 root 7. Is that useful?
Yeah.
Maybe the numbers are a bit smaller. This one square root 7, no choice. You have to come. Okay, actually, yeah, you can leave it as that. Then you just have to multiply top and bottom by root 7, and root x minus 1, root x minus 1. But okay, your method is fine as well. Just the numbers will get a lot bigger. Yeah. So multiply in, this is fine. This is 14. See, you have to factor out of 14. Actually, you could have factored out 28. Oh, but you factor out 14 so they can cancel. Very smart. Good. Next one. Okay, cancel off and you simplify to get this. The left side, just copy it down all the way. Fine. Next one. For a stationary point, equate to 0. Good. So this equal to 0. Yes. Multiply by 2x minus 2. Oh, no. This term bring over first. Then you multiply by 2x minus 2. Correct. Next one. 8 minus x equals 2x minus 2. You are losing some solutions. Correct way is to factorize. It's like, let me ask you, x squared minus x equal to 0. Some student do this, bring the x minus x over, you get x squared equal to x, then you divide by x on both sides, so x equal to 1. Then that's the only answer. Is that correct?
No.
What's wrong?
X can also equal to 0.
Exactly, after you factorize out, right? Then you can get x equals 0 or x minus 1 equals 0. Solve, you get x equal to 1. Same thing over here. There's a square root on the left, square root on the right. You could have factored out the square root to solve. Let me show you. So if you bring everything over to the left side, you get 8 minus x times square root whatever. Subtract away 2x minus 2 times square root of whatever equals to 0. Is that clear?
Mm-hmm.
Okay, good. So we sort of turn a fraction equation into a flattened equation, but you still need to bring it back to the left side so that you can factor out 28x minus 28. Multiplied by 8 minus x minus 2x minus 2. Is that okay?
Yeah.
Cannot use square brackets, make it look nice. Can, then open up the brackets, minus go in, you get minus 2x, with a minus x in front, become minus 3x. 8 minus away, negative 2 becomes 8 plus 2, which is plus 10. So 10 minus 3x. Times square root 28x minus 28 equals to 0. So as a result, you got something multiplied by something equal to 0. Each of the somethings can become equal to a 0, 0, 0. Right? Something times something equals 0. Each of them equals 0. Or in between, yes. And 10 minus 3x equals 0. So let's take a look at this first one, which is the one you're missing. You can take out a 28, which means you can split up the square root like this. Then you can take 0 divided by square root 28. That's just 0. I don't need the brackets anymore around the x minus 1. Square both sides, you get x minus 1 equals to 0 square. Right? Square and square root cancel. 0 square is of course just 0. So therefore x equal to 1. Okay.
Okay.
How about the other guy? 10 minus 3x, x equal to 10 over 3. Did you get that? 10 over 3? Okay, very good. So now actually there are 2 turning points. There's actually one turning point here, another one there. Okay. Let's just sub in the x equal to 1 into the length of the triangle. Okay, x equal to 1. So go back to the triangle. The question started with a triangle. When x equal to 1, what's the length? 6 plus 1, 7. 7. What's the bottom? 16 minus 2 times 1, which is 14. Okay, so that is possible as well. How about the other guy? If x equals to 10 over 3. 6 plus 10 over 3. 9 1/3.
9 1/3.
How about the other one? 16 minus 2x. Oh, it's 9 1/3 as well.
We check.
Huh? Yeah, go and check, go and check.
We check.
Yeah, I checked already. Yes, yes, yes. 6, do you know what I'm doing for this other? I am just, sorry, I didn't write this down. I'm just substituting with x equal 10 over 3. Then convert into mixed number. Okay, so now for this question, if you want to figure out which one will help you to maximize it, there's a simpler way to do it. If you, in the future, have access to a calculator. Let me bring up the page first. Hold on a second. Desmos, just draw the graph and you can see straight away which is the maximum, which is the minimum. Let me share the screen first. Okay, shared. Can you see the screen?
Okay.
Okay, so the function that we have for the area is area equals y equals 8 minus x multiplied by something. I also don't know how the graph looks up. I mean, not exactly until I do more things, like differentiation and stuff to figure out the behavior. But let's take a look at this graph. You see, it goes up and it goes down. Okay. So there's clearly a maximum point, and it's at 3.33. Oh, but what happens at 1?
What happens at 1?
Let me change the scale. Okay, that's how the curve looks. Up and down. So 1, 0, what does it mean? What's y? What's this function? Where did this function come from? Huh?
Where did this function?
Yeah.
Like the area.
Yes, the area. Okay, good. So so y equals 0 means what? The area equals to?
So y equals 0 means the area is 0.
Why is the area equal to 0? Let's go back. Yeah, cannot be, right? Cannot be from just plotting the graph algebraically. But let's think about it geometrically. Do you know something called the triangle inequality?
Mm-hmm.
Oh, you know about it?
No.
Okay. Okay, let's look at this then. So let's take a look at this triangle. Can this triangle exist or not? 16 minus 2 times 1 is 14. Okay, it's just 14. Length 14. 7, 7. Is it possible? Think of it like this. Think of a car, the windshield wiper. Wipe the water away. Okay. This is length 14. So if you chop it in the middle, let's say, then you get 7, 7, right?
Not possible.
Then if you bend it around like a radius of a circle, right? Like this is the windshield wiper. Would these two length 7s ever reach each other?
No.
No, right? So that means this diagram is wrong. The 7 actually only reaches until maybe somewhere here. Somewhere here. Let me just draw a circle to make it more convincing. Maybe I can make it broken. Yeah. And the other side as well. Duplicate. Clearly, you can tell by now that this circle does not, this triangle cannot exist. This is known. This is a simple rule known as the triangle inequality rule. A plus B must always be more than C in a triangle where the lengths are A, B, and C. Any triangle, obtuse triangle, scalene triangle. Scalene means all three sides are not equal length. Acute triangle, right angle triangle, anything. You must always obey this rule. Simply because of this diagram. The base length here, you don't have to split it in the middle. You can split it somewhere else here. So 8 here and 6 here also perfectly fine. You can draw this diagram and you convince yourself that the two lengths are, if they are exactly equal to the base length 14, add up to the base length 14, you cannot touch each other. It's too short. It has to be longer. Okay. 7 plus 7 is equal to 14. That's bad. You need 7 plus 7 to be more than 14 in a sense. Okay, not exactly 7, 7 point something, 7 points. Right, okay, that's triangle inequality. And also, you can think of it as the h equals to square root 28x minus 28. If you sub in x equal to 1, what do you get? H equals?
You sub in
X equal to 1.
x equal to 1, you get square root 0. Reject.
Which is 0. Can your height be 0? Cannot,
No,
because length
is
more
a
than
length.
Correct. Okay, so over here, technically, you want to solve for two possible solutions, x equal to 1 and 10/3, but you have to reject x equal to 1. Maybe if you sub into h equals to square root of 0, which is 0, then you reject since length is because length more than 0. Another way to answer this is your triangle will end up being 7, 7, 14, which disobeys triangle inequality. Okay. 7 plus 7 is not more than 14. Okay.
Okay.
Very good. So now we get 10/3. And so we must have a maximum. Okay. First derivative test. For maximum, if you do second derivative test, d2a by dx squared must be what? More than 0, less than 0, or equal 0. Which one?
If for maximum, it must be less than 0.
Okay, good. Can B7. Was that the one you?
Yeah, but is that the last part though?
Okay, I don't read first. I'll just read the question first. P7, let's see. Manufacturing. A closed cylindrical can of base radius r cm and height h cm is to be constructed to hold 250 pi cm cube. Show that the total area a cm square of the cylindrical can is given by that formula there. Okay. Let's see. Very good. Finally draw a diagram. Okay. Now pi r square h, that's the volume, our base area of circle. So pi r square here multiplied by the height equals to 250 pi. Good. So r square h equals to 250 because you divide by pi on both sides. Good. H equals 250 r power -2. Can? Can, because we're dealing with a can. Okay, never mind. So A equals to, what is it? The surface area. Here they are telling you it's a closed cylindrical can. So that means that there is a bottom and a lid as well. Includes both bottom and lid. Okay, good. So that means pi r square you have to times 2 because there's the base and the top lid. Okay, I don't put so many ticks, very confusing. Plus 2 pi r times 250 r power -2. That's 2 pi r, the circumference, multiplied by the height to get the curved surface area. Very good. And your the height h must be in terms of r, so that's why you did this and sub in. Very, very good. So now next one, you multiply in 2 times 250, you get 500. Pi is just pi, r times r power -2 becomes r power -1. 1 minus 2 is -1. So bring it down. Good, shown. Now area equals 2 pi r square plus 500 pi over r. That's good. Next one, the material for the curved side of the can costs 5 cents. Oh, sorry, no, 0.05 cents. So less than 1 cent. Less than 1 cent. We need 100 square centimeters to cost 5 cents. Yeah. Okay, it's less than 1 cent per square centimeter. Okay, and the material for the top and base costs 0.03 cents per square centimeter. Okay, somehow it's a bit cheaper. Part 2, find the dimensions of the can. If part A, the area of the material used is to be the least, the cost of the material used is to be the least. Okay, let's see. If you want to use the least amount of area, then we have the formula that dA in terms of r, then just dA by dr. That's that. That's exactly what you did. Let's see. Differentiate with respect to r, you get 4 pi r minus 500 pi. -1 bring down, you get a minus here and then -2. Very good. For stationary point, set it equal to 0. This is equal to 0. So what did you do next? Divide by pi on both sides. Divide by 4 on both sides. You get r minus 500 over 4. That's 250 over 225. R power -2 equals 0. Good. Then multiply by r squared on both sides. Okay, 0 times r squared is 0. R squared times r is r cubed. R squared times r power -2 becomes r power 0, which is just 1. 125 times 1 is just 125. That is fine. Don't need to write times 1. Bring it over, take the cube root, you get 5. Good. Then you do first derivative test, you get a minimum. Okay. Can. Let me think a bit. Yeah, correct. Okay, okay. Everything is fine. So find the dimensions of the can. If r equal to 5, then h equals to 10. Okay, okay. Can. Part B. So you want to find wait, let me read your question.
Yeah, I'm not sure how you do it with the cause you give 2 different like price. Then I'm not sure how you do it to make it least price.
No, what if you want to buy your own HDB, you want to design your own house, and you need to calculate cost, you don't know how to calculate cost. Oh no. Very simple, I teach you. So C is total cost. Okay, then there is one special part that is the area of the base, right? We already of the base and the lid, right? So it's just pi r square, but I got 2 copies, so 2 times. This part is the, what is it called? What they use, top and base. This is in what units? cm square, right? But now if you want to get the cost, you have to multiply by the rate.
0.05.
Huh? No. 0.03, right? This is
0.03.
So let's just put in the units. cm square. This one, cents per cm square. What happens to cm square and cm square? Cancel away, right? This is the rate.
Wait, don't tell me it's just this plus.
Yeah, it's just plus.
500 over.
Yes.
It's just like that.
Yeah, that's it. Yes.
Oh, I thought this is the type of question there's like d something over d something. Then you need to do like rate of change, and then you need to sub in because it's like for two different. Okay, never mind.
No. It's just a simple rate equation. Yeah. So just cancel away the common units. Let me write it nicely. C per cm square cancel off. Yeah, good. So you don't need to write the units. This is C cents. Okay, then drop the units now. So it just becomes C equals 2 pi r squared times 0.03, which is 0.06 plus 0.05 times 500. That will give you, let me check with our calculator first, 25. 25 pi over r. Let's rewrite it as 25 pi times r power -1. Okay, good. Now this time instead of a is c, so dc by dr, just differentiate off. So 0.06 multiplied by 2 pi r, oops, plus 25 times -1 pi r power -2. Correct so far?
Mm-hmm.
Can, right? Good. 2 times 0.06 is 0.12 pi r plus, okay, -25. Sorry, not plus, it's minus pi r power -2. Good. So now you want for stationary point, set dc by dr equals to 0. This implies that you go up, you copy, you paste it, duplicate, equal to 0. So from here, let's say we multiply by r cube. Copy your trick. Multiply by r cube. Very smart. Can. 0 times anything is 0. So that means the right side is equal 0. Left hand side, multiply r cube into the first guy, you get 0.12 pi r. 3 plus 1 is 4. That might be a bit too high. I don't need power 3. I just need power 2. Sorry. Let's change it. So r power 2 plus 1 is 3. Minus away 25 pi times r power -2 times r power +2. You get r power 0, which is just 1. Okay. Very good. 2.12 pi r cube will now be equals to positive 25 pi. Pi cancels away. R cube equals 25 divided by 0.12. Let's calculate this. 25 divided by 0.12. I get 625 over 3. Now if I take a cube root, let me see, cube root of 625 over 3. I get, wow, what's this? Interesting. My calculator gives me this 5 times the cube root of 5 over 3. Let me just share screen first. What a powerful calculator. Cannot bring into exam hall though. Can give you the cube root, the exact cube root. Okay, good. So this is, let's just use decimals, around 5.93 3SF. Okay, which means that your height h will be what? Height h was what was it? 250 times r power -2, right?
Mm-hmm.
Then in that case, h will be 250 times something power -2. That will be the 5 times cube root of 5 over 3. Let me just use the calculator. I take my answer, I have to raise it to the power of -2. And move it over. Yeah, raise to the power of -2, then times 250. Okay, so oops, that's not what I want. Interesting. The exact answer. 2 times cube root 3 square times 5. Cube root times cube root, I can combine together. So 2 times cube root of 9 times 5, 45. Approximately 7.11. Okay. Yeah. So sometimes in order to reduce the cost, you don't just minimize area. You have to depend on the cost of the material needed. And the cost depends on economics. Okay.
Okay. I can scroll up a bit.
Scroll up a bit. Let me know when to stop.
Oh, okay, yeah, you can stop. Yeah, okay.
Yeah, maybe I should label this. This is not top and base. This is what is it? Curved. Surface area. Top and base surface area. Units is cm square. This one is cents per cm square. Okay, good. Hey, anything else? No more. Very good. What other questions did I ask you?
Oh wait, I think I started on doing the next worksheet, but then there's like, I think there's
So
questions that I couldn't do.
Okay,
Then
I'll
that's
just
how. Wait, yeah, I started on the exercise 17.1. Then the question I couldn't do is you gave me question 2, 9, and 14. Oh yeah, okay, question 14, part 2. Yeah.
exercise what? 17 point.
17.1.
Okay, I just typed what you said. Very good. So let's go 17.1. Let me find it first. Where's my PDF? Sorry, which one again? 14?
14 part 2.
Okay, let's go. Should I just continue on the same worksheet? Wait a minute. Let me see. What do I need to send you first? In case I forget. I think I wrote some stuff. Let me see, not this one. This one. Right, this one. Okay, I'll send it to you later. Okay. Can. Let me just rename this. Oh, you sent a photo. Wait, need to go download it. Paste. Okay. Let me make one more change. Hold on a second. Need to make it a static image. Okay, let me share screen. What's the question? Let's see. Find the equation.
I'm not confident in what I sent you.
Okay,
Yeah.
I read first.
Okay.
Find the equation of the tangent and of the normal to the curve y equals 1 plus cos x at the point where x equal to pi over 6. So straight away, I'll just start by sketching a curve because they're asking for a tangent. It's a picture. Right, so just draw the curve at x equals to pi over 6 positive value. So I don't need the negative part of the x-axis. Right, enough space, hopefully. Cosine will be down, down, up, up, right? But wait, this is 1 plus. Maximum by default. 1, minimum by default, -1. So +1 means what? Means to move the x-axis down. Then everything +1. So this becomes a 0, this becomes a +2. The midline, the middle line, sorry, is a 1. Okay. What's this point here? What is the angle? Here.
90.
Huh?
Wait, 180, 180.
No, radians.
Or pi.
Pi. How about here?
Pi over 2.
Pi over 2. Very good. This one? This one?
3 pi over 4.
No, over 2. Sorry.
3 pi over 2.
Yeah. Hey, you notice the problem now, right? It makes sense to be 3/4, right? 1, 2, 3 of a quarter. But how come it's 3 over 2? So weird, right? So that's why you have this thing called the Tau manifesto. There's a group of people who think that pi doesn't make sense. Why is there suddenly a 3 over 2 here? We should use tau, half of a pi. So let tau be equals to half of a pi. Then this will be 1 tau. This will be 1/4 of a tau. Hey, is it correct? Let me think of it. Maybe I got the ratio wrong. 2 pi will be 4 tau. If I didn't remember it wrongly. So this is 1 tau. This will be 2 tau. This will be 3 tau. This will be 4 tau. Tau is another Greek letter. Makes sense, right? 1, 2, 3, 4.
Mm-hmm.
Yeah, but unfortunately, tau is not a standard notation, so you cannot use it during exams. You must use pi.
Wait, why is it not 3/4 pi?
It's 3/4 of this, which is 2 pi.
Oh, okay.
I only 180. Yes.
Yeah.
Then the 2 cancel. Okay.
Yeah, okay.
Right, okay, okay. Okay, good. Yes, that is the graph. Okay, moving on. So now we want the tangent and of the normal to the curve at the point where x equals pi over 6. So help me to remember this, please. Pi over 3, pi over 6. 30 degrees, 60 degrees. You see 3, do you think of 30? Wrong. Don't think of 30. Think of the other way around. Mix it around. 60 degrees. They are equal. You think of 6, do you think of 60 degrees? No. I was thinking of the opposite, 30 degrees. Okay, because pi is 180 degrees. So 180 over 3 is 60 degrees. Pi over 6, 30. The other way around. 3 times 6 is 18. Yeah. So when x equals to pi over 6, where is it? Not sure, then convert into degrees, 30 degrees. 90 degrees, to the left or to the right? Left or right?
Left.
Left, okay, so that means that we'll have a point here, pi over 6. Go up. We have a point here. So where's the tangent? Somewhere like this, let's say. Let me think a bit. Probably a bit more gentle, sorry. Something like this. Okay? Okay. Very good. So that is the tangent. Then find the equation of the tangent and of the normal. Wow. So this question very greedy. They want the normal as well. So at the point of intersection, you also want the normal, 90 degrees. 2 in 1, this one. 2 in 1. Find both. Let's call this L1. Let's call this L2. Okay.
Okay.
L1 is the tangent. L2 is the normal to the tangent. At that same point. So let's see, how do you do it? Differentiate with respect to x, sub in x equal pi over 6. You get differentiate 1 gets 0, differentiate cosine negative sine, sub in x equal pi over 6. Wow, finally the notation is perfect. Yes. Vertical line on the left, vertical line on the right as well. Then you sub in. Very good. Sine pi over 6 is sine 30, so that's a half, negative half. Good. That's the gradient of the tangent, slope of the tangent. Sub x equal to pi over 6 into equation 1, the original y. What do you get? 1 plus cosine pi over 6. Cosine 30 degrees, that's sine 60, which is root 3 over 2. Very good. Then use the equation of, use the point slope formula. Okay, so y minus the y coordinate equals to the gradient times x minus the x coordinate. Very good, yes. Then negative half times in, you get negative x over 2. Negative times negative gives you positive pi over 12. Okay, so far so good. Bring the rest over, minus bring over becomes a plus. So plus 1 plus 3 over root 3 over 2. Very good. Equation of tangent is done. Normal, just negative 1 divided by that gradient. So how I think of it is just multiply negative 1, like negative half. You times negative 1, you get positive half. Then you flip. You get 2 over 1, which is 2. So do these two steps, times negative 1 and flip. And you get 2. Okay, good. So just use the same formula again. The x and y coordinate is still the same because it's the same point. Just that the gradient is different. Very good. And just pick the rest. Yeah, 2 over 6 is 3. Yep, good, perfect. Very good. Equation of normal done. Part 2 Okay, part 2. I'll show that the area enclosed by the tangent, normal, and the x-axis is blah, blah, blah. Okay, let's take a look at the diagram. I need more space in the diagram. So I'll just copy and paste it over. Apparently, I do need the negative half of the y-axis. So what did they ask for? Find the area enclosed by tangent, normal, and x-axis. Okay, I have to call it a day for after this question. Is that okay?
Okay.
Okay, now, yep. So let's extend this red line. So where's the triangle? Here, right? Can see all. So in this case, what angle does it make over here?
90 degrees.
90 degrees. So we can do what? Half times.
Half times sine or times, I mean half
sine.
times A times B times sine C.
Don't need sine. About 90 degrees means can use the primary school style. Base times perpendicular height.
Oh.
Coordinate geometry. Yes. So what we really need is the length here and the length there. Okay. How to find length?
How to find length?
Coordinate geometry. Forgot already.
Like length of a line.
Yes. Let's call this P and let's call this, I don't know, Q, and let's call this R.
Okay. Square root.
But so, wait, before you tell me the formula, in general, what is it? What do you need to fill in inside the square root?
In general.
Yeah. What are they? What are those things? Where do you get those things you're gonna fill in underneath the square root from? The x2, the x1, the y1, the y2, and the y1. Where do they come from?
Where do they come from? What do you mean by it?
What is x2 and x1? What is y2 and y1?
What do you mean by that?
Like you tell me the formula is this guy, d equals, okay. Then how to use the formula?
Let's sub in the x coordinate of the, like, I can change the two, like you sub in the x coordinate for one point, then you sub in the x coordinate for the other point, you sub in the y coordinate for the previous point, then you sub in the y coordinate of the other point.
Okay, yeah, okay, good, correct. The point being point P and point Q, point P and point R, right?
Wait. Yeah. Okay. Yeah.
Correct? So all that you really need to do is to first figure out what are these coordinates. Then after that, just throw that formula. You got a D
Okay.
for the first one, D for the second one, half times base times height. That's it.
Okay. For
You wanna try
point
on your own?
for point P is just make the tangent equal to the normal.
Tangent equals to the normal. Yeah, can.
Then you can solve for point B.
But there's a simpler way. It's
Sub
also
x equals to pi over 6 into the tangent.
into the tangent can. I was thinking of the curve,
Of the curve.
Yeah, just 1 plus cosine pi over 6.
Oh,
Because the black color is part of the curve. So this is a point that lies on all three lines, all three graphs. The red line, the blue line, and the black line. Intersection, like Toby got. Intersection. What's the colors? Red, purple. Okay, I can't remember. But okay, very good. That is how you find out why.
What about for Q and R?
What do you think?
Sub y equals to 0.
So y is 0.
Sub y equals to 0 into the for Q sub y equals to 0 into the tangent.
How what?
And then for point R is sub y equals 0 into the normal.
Yep, very good.
And then you can find the coordinate. Then after that, you just find the length of the line. Then after you find the length of the line, you just find area of triangle using length times breadth. So it's PQ times PR times half.
Exactly, you got it. Okay, I will leave you to fill in the details on your own.
Okay.
Yeah, this is the idea. So here, this one is the curve. Of course, you could also sub in into what you said, sub in into the tangent. What's the equation of the tangent? It's over here, right? Negative x over 2. Negative x over 2 plus pi over 12 plus 1 plus root 3 over 2, where the x in this case is pi over 6. Simplify this, I think you'll get the same answer. Is it not? Cosine 30. Yep, you'll get the same answer. Okay. Ken, that's all.
Okay, Ken.
Yeah. Keep trying. So you just finish up that practice, the remaining part. What is it? Revision exercise 16 done. So it's just exercise 17.1.2.3 and RE 17. Okay.
Yeah.
Do you want more?
I don't know if I can finish all of the things you just said.
Yeah, those are the ones that finally involve the transcendental functions, e power x, ln x, tangent, sine, cosine. Okay, so you're gonna do everything again, but it's just with those special functions.
Okay.
Yeah, that's all. If you have extra time, go and do the rate of change worksheet, which we have. There were still a few questions you haven't finished. Oh.
Okay.
Okay, Ken. That's all. Bye bye.
Thank you. Bye bye.
Thank you. Bye bye.